All right, great. Thanks for confirmation. So the program name is Zero to Lab because we are going to prepare for the CCIE Lab, and of course CCIE also has many different pathways. One of them is enterprise infrastructure, which used to be called CCIE routing and switching. So this program is actually designed to prepare you for CCIE enterprise infrastructure exam. Right? There are other streams as well. Like you can go for wireless as well. Collaboration is there. Security is there. But I've always believed that routing and switching or enterprise infrastructure is the base for everything. So once you have the core knowledge, then everything else becomes easier to understand how the security works or how the collaboration works, how wireless technology works, because you need infrastructure for everything. And once the infrastructure is set up, your core foundational knowledge is strong about how the packets are moving, how the frames are moving, and what could possibly create issues and how to troubleshoot them. Then it becomes easier to grasp other aspect of the technologies as well, right? So in this particular presentation, I'm going to show you exactly what is expected into the CCI exam and what are the topics that we are going to cover throughout the duration of this course, and then how this course is structured so that you understand what to expect, and finally, of course, what is expected from your side. So let's get started. The very first thing is that let's talk about the exam itself. Like, of course, because our objective here for this course is to make sure that you can take the exam and pass the exam, CCI enterprise exam, enterprise infrastructure. So the exam is actually divided into two parts. So it's an 8 hours exam. So when you go for on the exam day, you will see that the lab part is total 8 hours. But before you can go for that full day exam, you have to do a qualifying exam, which is a written exam or a multiple choice question exam. So this is called the qual exam or qualification exam. So earlier, what used to happen, CCNA was a certification, and then there was CCNP. So route, switch, and T-shoot. There used to be three different exams, and then you became CCNP. And then when you wanted to do CCIE, you had to do a dedicated CCIE qual exam. There was a dedicated written exam for CCIE. It used to be called CCIE qual, and then only you can actually book your lab. That was the structure that. But now what happened? Now what's happening is that you do your CCNA, and then for CCNP, it's divided into only two exams. So one exam is called the core exam, which is called NCore 350-401. And then one of the concentration exams that you can choose whether you want to do NRC or you want to do the SD-WAN based exam or wireless based security based. So one of the concentration exam you have to pass, and then you become CCNP. But the good thing is, while you are on your journey of CCNP and you, let's say you pass the NCore exam, you become qualified to book the lab exam as well. So now the NCore exam, which is one of the CCNP exam, also plays as a qualification exam for CCI. So you don't need to uh, spend more money for a dedicated written exam for CCI. That used to be the case before, right? So CCNP NCore 350401 is the exam that you need to pass before you can actually book the CCI Lab exam. And you don't need to book it immediately. You get 3 years because NCore is actually valid for 3 years. So within 3 years, you can book your CCI Lab exam anytime, and it will still be valid for that. So this is the first part, qualification exam. And once you pass the NCore exam, then you can actually start preparing, or you can start planning to book for your lab exam. And the lab exam is called CCI Enterprise Infrastructure. And now it is actually version 1.1. So we have also updated our trainings according to that. So version 1.0 was the original version, and then 1.1 are the slight differences are there. And I'll show you exactly the latest blueprint that is there, what is expected in the exam. And this exam, the lab exam itself, this is divided into two parts. So it's an 8 hour exam. So on the lab day, you will have to travel to one of the exam facilities. I think during the COVID, they also allowed it to be online, but I'm not sure if it is allowed anymore. I think the CCI exam was halted anyway, but you have some permanent lab sections or lab offices. For example, in India, you have one permanent lab. In China, in Beijing, you have, in Hong Kong, you have, in America, you have many, like in RTP, San Jose, Sydney, I think you have one permanent one. But then there are some other locations, like if you want to do it in Thailand, Bangkok, there is no permanent lab location, but there are mobile labs which you can see the dates and you can book accordingly. But you need to travel and you need to do a 8 hours sit down configuration exam. So it's an 8 hour hands-on based exam, and this is actually divided into two different parts. So the first part is called the design part, and this is going to be 3 hours. So when you go for the exam in the morning, the first 3 hours will be the design part, and this is actually an easier part because you don't need to configure any devices. It's actually MCQs, multiple choice question, drag and drops, but no configuration. So this is more like your written exams, but you need a little bit more deeper understanding of the topic. So if you have done your fundamentals right while we are going through the course, and that's what we will make sure that your fundamentals are very strong, then this part will become very easy. For example, if a question is about why OSPF neighborship is not coming up, and maybe they are showing you, they're showing you an exchange of an email between end user or maybe the network administrator and one of the junior configuration engineer, then it will show you the outputs maybe like of the configuration or some of the show commands, and you will have to find out what's wrong, why OSPF neighborship is not coming up, and then you will have to choose one of the options from the multiple choice questions, for example. So if you already know what are the components of an OSPF neighborship that must match and what components must not match into a hello packet, then you already know where to look and what to check. Like MTU must match, the timers must match, authentication must match, area must match, the network must match, router IDs must not match. So they have to be unique. So if these things are clear, the fundamentals are clear, it will become very easy to solve this part, the design part. That's why when you do the lab every week, you are doing the configuration, you gain that confidence to actually solve these kind of issues as well, because these issues are also practical based, just that you don't get to configure anything. You just need to answer based on your observation. So that's what you need to check. On the other hand, after the design part, you have the second part, which is the 5 hours part, deploy, operate, and optimize. This one is going to be 5 hours. And here you will have to configure things. So you will get a topology and you will start configuring the topology. And you will not configure it from scratch. So IP addressing will already be there. Some routing and switching will also be already configured. You just need to fix things or configure things which are missing and just making it working normally again. That's what you will have to do. So there will be three major sections in these 5 hours. First part, I like to call it the routing and switching, although this is not the official term, but all the earlier routing switching topics, like all the switching concepts, all the routing protocols, multicasting, QoS, IP version 6, TMVPN, MPLS, all these things will go into the routing and switching section. Any kind of IP services like DHCP, DNS, or network address translation, NTP, SNMP, syslog, netflow, all these things will be into the routing and switching section, section 1. So your core switching and core routing will be in this first part. And then the second part or the second section is SDN, or software defined networking. So that's where we will be using the concept of software defined networking, or SDN, into the LAN as well as in WAN. So when you use software defined networking LAN side or in the campus side, it is called SDA, software defined access. And you use a controller called DNS Center, Cisco DNAC controller. And if you are using the software defined networking on the WAN side, it is called SD-WAN. And there is a Cisco Viptela solution for SD-WAN, which we are going to learn as well. So we will get in-depth understanding, and we'll do the practicals also for this part. And of course, programmability is the last part. So this section is the smallest one, programmability part. But of course, you do need some knowledge about programmability, which I'll show you in the blueprint in a few minutes, that what exactly is expected. And don't worry, we got you covered for whatever you will need into the exam, making sure that you not only just remember them, but you understand the concept as well. Like we will understand the different data formats like JSON, Jinja, and XML. We'll also understand the different networking protocols like RESTconf and NetConf, and how we can use them to retrieve information from the networking devices, as well as change the information on the networking devices. So you can actually send a netconf request to configure an IP address and enable the port on a router, or to configure something on the switches. So you can do that. As well as we will also learn automation. So we will learn Python programming. So we will see that how we can create Python programs to automate these things with the netconf and restconf request that we can send. And we will also see some client-side software like Postman, so that we can use that to send the RESTful APIs to the devices to either retrieve the information or to change the information on the networking devices, or SD-WAN or SDA devices. You can actually send these APIs to any of these devices which are ready to receive these instructions. We will also learn EEM, embedded event management, which is in-house scripting programming language, you can call it, or programming function you can call within the Cisco iOS. And the EM and Python can be mixed as well, and that becomes very powerful. So you can actually trigger a Python program based on an event that happened on the router. So let's say if the memory or processor consumption goes beyond a certain point, you, instead of taking few trivial actions, you can trigger a Python program which can actually do more detailed things using netconf or restconf, and make significant changes into the router or switch, so that you can take the necessary actions that you need to take. So all these things also we are going to learn, which will be part of the programmability, right? So if I show you the basic blueprint of CCIE, you will see that currently the version is 1.1, and in this one we have many different sections. Especially routing and switching part is very similar to what you used to have earlier, but new things like SDN and programmability are also there. So first part, network infrastructure, where we will start with layer 2, and we'll understand the switching. So we'll understand the switching, MAC address tables, error disable concept, and also protocols like CDP, LLDP, or UDLD, which are used for layer 2 finding out your neighboring devices, or finding out any unidirectional links. VLANs, of course, VLANs and trunking, we will understand them in detail as well. So this is something you learn right from CCNA, and then CCNP also, and then again in CCIE. But we will learn more details about those things, right? Ether channel, of course, one of the big topics, and spanning tree protocol. So one thing you will notice is that because they introduced newer topics like SDN and programmability, they have decluttered switching a lot. There used to be lots and lots of other topics as well into switching. For example, IRB and CRB, integrated routing and bridging, concurrent routing and bridging, and then other some flexible switching topics as well. Some of the older layer 2 technologies like triple P and ML triple P, authentication over point-to-point links. So those things are also now removed, and they are concentrating only on the core switching technologies, which is a good thing because we can go more in depth, and we can actually understand it more deeply and become more confident about the core technologies like STP or VLANs or Ether channel, and we don't need to worry about 100 other different switching things which are smaller and might not be necessary in the newer implementation. So they kept switching very clean. And then we move to the routing part. And in routing, of course, we have the basics of routing, static routing, what is AD, PBR, policy-based routing, what is VRF, and what is VRF Lite. So VRF is a concept used in MPLS. We will learn in detail. But you can use VRF without MPLS also, which is called VRF Lite. And you can run any routing protocol over this VRF Lite as well. Basically, dividing your same infrastructure between multiple businesses. So you can keep their routing tables completely separate. So you can run two completely separate businesses. They do not exchange any routes to each other, but using the common infrastructure by dividing the routers and switches logically into multiple devices. That's called virtual routing and forwarding, or VRF. So we will, of course, learn in detail these things as well. Route leaking between different VRFs, that is also something we can do. Route filtering, redistribution, so all your routing, advanced routing concepts, authentication, BFD, and all these things. And then we will get into the in-depth details of two IGPs, EIGRP and OSPF. So in EIGRP and OSPF, we have again these things also we learn right from CCNA and then CCNP, but we will go into a little bit more in depth on both of these routing protocols. RIP, as you can see, is no longer part of CCI, so that makes sense. RIP version 2 is a very limited protocol, so it's not actually part of the CCI curriculum anymore. And of course, for the EGP side, exterior bit protocol, we have BGP. We learn border gateway protocol and what is the difference between IBGP and EBGP, the different aspect of it, path selection, that means the path attributes that we will use and how the path selection procedure works. So there are 11 path attributes which are checked and how exactly and in which order they will be checked. All of these things we are going to learn in this. Routing policies, AS path manipulation, convergence and scalability, which means route reflectors and aggregation, AS set. All these things we are going to learn here as well. And configuring other features like soft reconfiguration and route refresh, which is actually pretty easy, but very, very important to understand or important to remember. Some things, as you can notice, they are keeping BGP also very clean. So BGP is a huge protocol. And if you go for CCI service provider, for example, you will see the real power of BGP because their CCI service provider is completely MPLS, pure MPLS, and MPLS is impossible without BGP. So there are so many different aspects you use there, but here they are keeping it only strictly so that it can be learned from the enterprise side, right? That's why I see that they do have route reflection, but configuration is not there. But I would say that we are going to learn like kind of a BGP plus because I will teach you a few more things that you need just for the exam. Like we will definitely cover configuration as well because it perfectly complements route reflection. So it makes sense to understand that part as well. And some other advanced filtering technologies and regular expressions we are also going to learn properly as well, right? So all these things we will cover. Multicasting, of course, and QoS and everything will be shown later. And then come SDI, software-defined infrastructure, where we have the LAN side SDN, and then you have the WAN side SDN, SD-WAN, which is called. So SD and SD-WAN we are going to learn in detail as well. Now remember, software-defined networking simply means when you decouple the data plane and control plane. So all the devices had separate control plane, and then you need to configure routing protocols there to exchange routes between them, and everyone is independent of taking their own decisions, right? But in SDN, what happens? You decouple them and you take the control plane out from all the devices and you place them into a central location called the controller. So SDN controller. So in the LAN side, it is called DNAC, DNS center. In the WAN side, it is your SD-WAN V smart controller. So you can see that these are the different things that we are going to learn in SDN, that how do we actually implement them. And of course, we have the full labs for this as well. So we will practice everything properly, right? And then comes some transport technology and solutions. That means the VPN solutions like GRE tunnels, MPLS, L3 VPN, and DM VPN. So dynamic multi-point VPN. That is also we are going to learn in detail. And then, of course, your IP services and security services that we had in the earlier CCI as well, like AAA or ACL, router security features or IPv6 security features, as well as some device management, like how do you configure console and VTY, how to access device using secure shell, and of course, RESTCON and NetConf we are going to learn in programmability part in detail. SNMP login, QoS is a big part as well, and network services is also regular, everything that we generally had before as well, SSRP, NTP, and Slack and everything, right? So these are things we are going to learn. Network address translation we are going to learn in detail. IPS array, of course, and network operations, SPAN, RSPAN, ERSPAN, everything will be there. The last part is very interesting because that is completely new in the CCI exam, infrastructure, automation, and programmability. So this part, we are going to learn the different data formats, that how you can actually represent data. And then we are going to learn automation, where EEM applets means embedded event manager. I will show you how to configure it, how to use it to call a Python language, a Python program as well. Guest shell is very interesting. Guest shell is where you are actually running Linux operating system inside the router. So inside the router, you will have a container, a small container, which will be running Linux operating system. And from there, you can run Python, which can directly interact with the router to make changes or to get the information. This is called guest shell. And it's a very interesting concept. And we are going to learn this as well. And of course, then we are going to learn Python and how we can use Python to call RESTconf and NetConf and use Postman as the client side software for that purpose, right? So we are going to learn different Python libraries. We are going to introduce Python. So if you don't know Python at all, don't worry. We are going to go through the basics first, and then we will talk about the network-based applications, so network-based code that we can write into Python, right? So this is the basic uh, idea about the syllabus of CCI that we are going to cover. And going back to the presentation, how exactly this program will work, we will see. So before that, as we were talking, that there are three major sections as we just saw. And as I mentioned already, devices will be partially configured already. So you don't need to configure it from scratch. You will just need to configure the devices as per the instructions. So if some OSPF configuration is missing, like a neighborship is missing somewhere, you need to just fix that and you can move on. Some other things like maybe like DMVPR or MPLS, you may have to configure more things. A little bit will be configured and more has to be configured there. But yes, of course, you will not get a blank topology. You don't need to worry about that. So this is a big task. As you can see, there are so many different topics and the structure is very important. And we had noticed that many boot camps, they are only 5 days to 10 days, and going through so many topics within a span of 5 to 10 days and not giving time to practice, it's not going to help anyone. It might be good for someone who is already ready for the exam, just already booked, maybe next week or in a couple of weeks he has the exam and just want to go through everything again very quickly. Even then, I don't think you can retain that much information within 5 to 6 days. So we wanted to create a course structure which is slightly slower in the pace, and we cover a particular topic in depth, and then we give you time to do the labs at least 2 3 times in a week, and then come back for the next topic, so that you register the information and then you repeat it by doing the labs yourself, and that way it becomes very comfortable to do the configurations. So the concept become clear and configurations become natural. That is the objective of this course. That's why you see that this is once per week and it is going to be 2 hours per session. So how we are going to structurize this in a once per week program is that 1 hour will be the instructor-led topic discussion. So, for example, let's say we are starting OSPF. I'm going to go into the detail about how the OSPF work and exactly what you need to know. And of course, OSPF is a big topic. So we are not going to have a single week for OSPF. We might have 2 or 3 weeks for OSPF. Same thing for BGP. But if it's a smaller topic, first, let's say CDP or LLDP, 1 hour will be enough to explain you the details that you need to learn about that topic. And then, of course, the second hour, I'm going to do the lab based on that topic or the part of the topic that I would discuss that day. For example, if I'm talking about OSPF neighborship, authentication, and timers, and the basic OSPF neighborship troubleshooting, then the lab will be based on those topics. And I will start the lab. I will configure the lab in front of you, so you will see that exactly for every topic, every question, how the solution will be. And for this, we have different labs. We have created PDFs for every topic, and we will go through instruction by instruction, just like in the real life, just like in the real exam, right? So I will be reading the question. I'll be explaining you how the answer would be for that question, and then I will be configuring it. So it will become very clear what you just learned. You see it implemented as well, right? And then, of course, the same lab along with the solution file, I will send you using email. And then you will have to do that lab during the week. So, of course, we have one session per week. So let's say I covered some part of the BGP this week, let's say route reflection and configuration, and I did the lab, so you understood it. And then I'm going to send you the same lab so that you can also do it. And once you do the lab, you can actually send me the solution on the email so that I know that you have completed the lab, or at least a confirmation that you did the lab as well, right? Of course, because I'm sending you the solution file also, I will be sending you the solution file. So if you have any issues, you can refer to the solution file. Because remember, don't test yourself. So for the duration of this course, just have the mindset of learning, not the mindset of testing yourself. So when you are doing the lab on your own, that time also you are learning. So if you get stuck somewhere, feel free to check the solution file and then you will say, oh, okay, this is how it is done. So the next time you will do it, you will remember it and then it will register in your mind, okay, in your brain that this is how it is done. And even if the scenario changes, the concept remains same and you will be able to tackle that, right? And in case sometimes the solution file is not clear, what I mean is that you don't understand why the solution is like this, why cannot be it like that. So you can definitely ask me. And how do you ask me? So in every session that we will have, there will be a Q&A session as well at the end. So after I finish explaining the topic and done with configuring the lab, I will say, okay, are there any questions from this week or from last week? You can actually note them down and you can ask me that time. In case if you get stuck somewhere in the middle of the week and you want to ask question that time, not you don't want to wait for the whole week or the week for the next session, you can definitely ask on our Facebook group. So we have a Facebook community created for Zero to CCIE, and there we have many students who are also very helpful. So what will happen is that if you post a question there, of course I will answer, but it is possible that maybe someone else will also chip in and will give their perspective. So it's a good thing, and maybe someone else also wanted to get the answer for that question. They can also get it there. So it's better to ask there, and also you will have the recordings for this. That means the recordings will be available for lifetime. So whenever you want to go and watch the recording again, you can do that. And below the recording also there is a comment section where you can ask question and I can answer there as well, right? Uh, on the email, we don't actually reply for the questions because emails we are just using to send the lab. So it is not monitored for any questions. So it's better to ask on the Facebook group or within the session. You can ask me directly or below the pre-recorded videos which you can watch again, right? So this is the course structure. And when you think about this course structure, how it can help is that in most of the programs, the main thing that is missing is practice, a lot of practice. For example, if I tell you how OSPF work, you will understand it and you will say, yeah, that's pretty nice. But then you will forget about it in few days. And then again, you will be confused. But if you can practice it immediately, few times, and you will have the labs and we will give you all the practical means to practice it as well. So you can do it as many times as you want. And you can create a repeated program as well. Like every few weeks, I will come back to OSPF labs and do it again. That repetition and lots of practice will register everything in depth in your brain, and then it will become second nature to do these kind of labs, right? And that is very important for passing the exam. So that's exactly what we address in this program. So for example, all the single protocol labs are configured and explained by me, followed by the configuration by candidates during the week. So these single protocol labs, let me give you an example. For example, we have a BGP lab like this. So I'll send you this diagram also. And I'll say you have to configure BGP according to this diagram. So you can see that there is autonomous system 100, autonomous system 200, and autonomous system 300. These are like three different organizations. AS100 is using RIP as the interior protocol. AS200 is using OSPF within their organization, and AS300 is using EIGRP as their IGP, right? So then you need to configure BGP. But how do you configure it? Do you do it on your own? No, you will do it just like CCIE exam. In CCIE exam, you will have instructions, do this, do that, and then you will have to configure it according to instructions. So we also have created labs similarly, but because this lab is concentrating only on BGP, a single protocol. So that's why it is called a single protocol lab, right? So in the exam, everything will be mixed, which is called multi-protocol lab. So to give you an example of a single protocol lab, uh, the lab will be this, something this I will send you like BGP lab 1, where I will tell you what to do. Configure RIP between router 6 and router 7. You need to advertise their loopbacks in RIP, but don't include the link which is going to another organization, right? Similarly, configure OSPF in AS200 and configure EIGRP in AS300. And then you have to do configuring of IBGP according to these rules. So between router 2 and 4, we want loopback to loopback neighborship for BGP. So create two static routes, configure full mesh IBGP. Remember, this is not something that you have to know already, because in the session, I will explain you how BGP works and I will tell you in depth how exactly to configure BGP. and then I will do this lab, exactly this lab in front of you. So you will have exact solution how to do it. Because again, the objective is not to test you. The objective is to teach you and to make sure that you become comfortable with the technology. So don't test yourself, just have a mindset of learning, right? And of course, along with this, I will send you the solution file. And in the solution file, you will see exactly what you need to do. For example, OSPF configuration and then BGP configuration according to the requirement. Everything will be there. And because I will be configuring this into the live scenario, live Zoom session as well. So if you have any questions, you can directly ask there, or later also feel free to ask me if something is not clear into the solution file. But definitely you can refer to the solution file. Absolutely no issue at all, right? So all the single protocol labs are configured and explained and then sent to you as well. And of course, we have the detailed solution file, as I just mentioned and showed. There will be Q&A sessions to clear any doubts. So we don't want to leave you alone at any point of time. So if you want any help, the help will be very near to you, and you will have all the resources to start your journey for your CCI learning. Of course, how this program can also help you is that we cover all the advanced topics as well, which are there into the CCIE, SDN topics, programmability and automation practicals, and we also have the multi-protocol labs. So of course, we will go through every topic every week, and we will be doing single protocol labs, like some week OSPF, some week BGP, some week MPLS. But once we are done with the core topics, we will also have the multi-protocol labs where we will configure everything into the same topology. So just to give you an example, this is one of the multi-protocol lab that we will do, where you can see that we have a big topology where we have the data center and headquarter, and these data center and headquarters are connected to branches here, branch 3 and branch 4, using a service provider. So you will have to configure MPLS into the service provider. You will have to configure some kind of IGP like OSPF or EIGRP within the branches. And to connect data center to the branches, we will be configuring DMVPN as well. So you will have to configure DMVPN as well. You can see that you are configuring multiple technologies here. That's why it is called a multi-protocol lab. Similarly, for SD-WAN, for example, we also have a multi-protocol lab where you can see that we will have the vBond, vSmart, vManage, and then we have the edge devices VH21, 22 connecting over a service provider network to VH40, 51, and 52 in branch 1 and branch 2. So at the end of this multi-protocol lab, you should be able to communicate end-to-end by exchanging routes using SD-WAN or software-defined WAN. Just to give you some examples. And similarly, we have Python programs, we have Postman software, and we have RESTconf and NetConf examples. So all these things will also be included in this. So it is a complete package. You will learn everything. Of course, troubleshooting is also a big part of the exam. And troubleshooting is one of my favorite topics. Why? Because troubleshooting directly depends on your foundational knowledge. As I was telling you earlier, with an example, if an OSPF neighborship is not coming up, all you need to know is what is needed for OSPF neighborship to come up. And you just need to check those points and you will find out what is the issue, right? Similarly, if your BGP routes are getting dropped somewhere, you need to know that is it getting dropped because of the lack of information, which is called control plane, or is it because somebody is using some filtering, which is data plane? So when you have your concepts clear, troubleshooting becomes second nature, because you just need to check how it's supposed to work, and if it is not working like that, what is the missing link? That's troubleshooting. So you will see that once you learn all the concepts in detail, in depth, troubleshooting will become very easy for you, right? And of course, my support will be there throughout the course duration. So one of the things which you will find about me is that I love teaching, I love training, and although it's a cliche, it's my passion. But the thing is that when there is a concept that I can explain, and you say there's an aha moment that you say, yeah, now I understand this, that makes me very happy. So I will be here making sure that you are on your path. Of course, there could be some times where you will be slow, sometimes you will feel more motivated, but always remember, motivation is overrated. Discipline is what you need to have. Consistency is the key. whether you are feeling it or not. That's why we have the live sessions. Otherwise, we have a very in-depth program, Zero to CCIE, which is a perfect companion for this one, because you have very in-depth videos there, and you can always go back to those to have more in-depth understanding. But if you are just on your own, sometimes you don't find the motivation, or you the life kicks in, right, and you lag behind. So we just want to make sure that doesn't happen, and that's why my support will be there throughout. And feel free to get in touch with me for any kind of questions, and I'll be more than happy to answer you, right? All right. And of course, you will have the lifetime access to the class recordings. So the class recordings might be from our class or might be from a previous class that we had for the same course, but the topic will be same. So you will get the class recording. So the core of the topic will always be available to you. You can actually watch the recording anytime, and it's a lifetime access. So all will be good with that, right? Excuse me. So what tool do we use for CCI? So for as far the tools are concerned, we are using EVNG on VMware. So EVNG is a free software which allows you to emulate a routing device, routing and switching devices. So it's an emulation software, means it doesn't just mimic the routers or switches. It doesn't pretend to be router switches. There is actually a iOS image, operating system image in the background. So you are actually dealing with the real operating system of router or switch. Just that the front end is not a hardware; it's just a software. So that's why we are using EVNG. But if you want to use EVNG on your own, it's completely free. You can go to evng.net and you can download it. The issue is that it's just a program. So if you want to use any router switches, you need to find their correct images somehow, and then you need to upload them to EVNG. Then you have to install their licenses. Without proper licenses, they will not work. And then you will have to create the topologies. You have to think what topologies you can create, and then you can start practicing. So we wanted to remove all this from your path, because we wanted you to concentrate directly on the technologies from day one. So we have created an OVA where I have packaged everything already. I have already copied the iOS or operating systems to the EVNG, installed all the licenses, created the topologies that we will be using, and it is all packaged into a single OVA. So all you need is VMware workstation or workstation player. You need to install on your system, and we recommend Windows operating system because it's easier to troubleshoot. Otherwise, there are some issues with other operating systems when it comes to troubleshooting. And then you just need to import the OVA, right? So you just need to import the OVA into VMware, and then topologies are already set into EVNG. And the lab files that I will send you every week, they will be based on the topologies into the EVNG, right? So yeah, I was saying that the solution file will also be sent along with the lab file. This is something we already discussed. And during the off days, we recommend you to, we encourage you to do the labs more and as many times as you can, so that you become very comfortable with this, right? So for the EVNG, I will send you the OVA, and topology will be already set. The thing is that we recommend to have at least 8 gig of RAM in your system, uh, minimum. But if you have 16 or 32 gig, that will be better. The reason is because for SD-WAN, you will need more resources, especially for vManage. It actually is very resource hungry. So 16 to 32 gig is better. So the sweet spot, I would say 16 gig. If you have a 32 gig laptop or desktop, that's great, because CCI is a big step and it's a long-term project. So I think it's worth investing a little bit in this. So maybe you may purchase a dedicated desktop for this with 32, 64 gig RAM. But if not possible, then at least 16 gig is what I would say, so that you are covered for both core technologies and as well as for SD-WAN, right? One thing though, that after importing OVA, make sure that you adjust the RAM, because I will send you the OVA from my desktop. I might be using different RAM because I have 128 gigs, so I might have given it more. So adjust the RAM and set the first interface to NAT, so that your IP addressing is proper as well. So this is something you can see in this example. So when you go to the virtual machine setting, make sure that the RAM is set to whatever level you want to set. Let's say 8 gig or 16 gig, And network adapter number 1, set it to network address translation. That will be perfect, right? All right. So that's the CCIE structure. That's the course structure that we will start from next week. But what is expected from your side? So from your side, I just need you to show up, because as I told you, consistency is the key. As long as you are continuously joining the course or joining the live session, you will be motivated to do your work, right? Show up, do the lab, and ask questions. These are the things. And of course, be consistent so that you can see your progress yourself as well. So, little bit about myself. I have 16 years of network training experience. More than 11 years out of that is dedicatedly CCI training experience. And I have 2 CCIs. One is in routing switching and one is in service provider. And I also have practical experience from consultation work that I do for different service providers. So many times I also include the real time examples, real life examples as well into the classes because of this consultation work. So that's it from my side. Let's get started. Thank you. And if you have any question, you can ask me. Let me allow you guys to unmute in case if you have any questions.
No questions from me.
Yeah, thanks, guys. So in case,
nothing from me either.
Okay, thanks, Matt. So just in case if you have any issue with EVNG, you have this week, you should solve it. Although I think the first lab we have is about subnetting, so that will also be theoretical. So I would say you have 2 weeks. In case if you have any issues with EVNG or setup before we start the actual practical labs, you can get in touch with me and we can fix it. All right, guys. So in that case, I would say thanks a lot for joining today and exciting times ahead. So I'll see you guys next week. Have a good night.
Thank you.
Thanks, guys. Good night.
Thank you. Good night.
Yeah.
Thank you.